Hello friends, I am Professor Ranjit Singh. I am Chairperson of Industry 4.0 under the Skill Faculty of Engineering and Technology. I am also the Dean Affiliation of Shri Vishwakarma Skill University, Palwal, Haryana. Today, I am going to discuss the transfer function of control system. Before starting this, we must be able to understand what is the objective behind this topic. The main objective is to understand the two type of the control system, that is open loop control system and closed loop control system. The second aim and focus of this topic is to know about the transfer function and its analysis for control stability. The learning outcome of this topic is to expose the student about the representation of control system and their analysis, particularly for open loop control system and closed loop control system. Before discussing the transfer function, we must understand what is control system. Control system means to manage, regulate or command the devices or the system according to the control loop. In the simple word, we can say the control system is the manipulation or the guidance of the system according to the desired condition of the users. The control systems are classified into number of the categories on the basis of the principle of superposition or the linearity. We may call a control system as a linear control system or non-linear control system. On the basis of the variation of the time, we can classify the control system as a time variant control system and time invariant control system. On the basis of the continuous and discrete signal, we can classify the control system as a analog or digital control system. Similarly, on the basis of the mathematical tools like the state space representation, we can classify the control system as a traditional control system or automatic control system. There are other few categories in this manner, but there are only two type of control system, that is known as open loop control system and closed loop control system. Before discussing much about transfer function, we must understand what does mean by open loop control system. Open loop control system are those systems in which there is no feedback mechanism. There is no relationship between output and input. While closed loop control system are those systems in which there is a relationship between the output and input, and error detector is used to get the desired output for the system. Open loop control system are also known as non-feedback control system, while closed loop control system are also popular as a feedback control system. The accuracy of open loop control system are less in comparative to closed loop control system, because in the closed loop control system we are using the error detector to remove the deficiencies or the errors which will give us the more precise value. The response of open loop control system is much faster than closed loop control system, because there is no feedback mechanism in the case of the open loop control system, and we will have the direct relationship of the output with input as a response. So we will get the fast response as compared to the closed loop control system. The cost of the closed loop control system is more than the open loop control system, because in this case we are using the error detector, we are using the feedback process that will give the more cost toward this system. Open loop control system are less optimized, while closed loop system are more optimized, because the error has been removed by the use of the error detector. The major differentiator between the open loop control system and closed loop control system is tabulated here in this diagram. We are looking that the stability of the open loop control system is more than the closed loop control system. This will be more clear with the transfer function. The transfer function of the any control system means it is the relationship between the output and input. Transfer function is a compact way to represent the output and input. It is a mathematical model according to the Laplace transform of the output and input. The transfer function is defined as the Laplace of the output with respect to Laplace of input, keeping all initial condition to be 0. This is a major and important condition of transfer function, that all initial conditions are supposed to be 0 while calculating the stability of any type of the control system. Let us assume the open loop control system. In the case of the open loop control system, as a linear time invariant system, as a LTI system, the RT is the input of a system which is represented as GT, and YT is the output of that system. In the case of open loop control system, the transfer function of the open loop control system will become, after converting this differential equation into the Laplace transform, as the input will convert from RT to RS, the system will convert into the GS as a Laplace transform, and output YT will change into YS. Now, the overall transfer function of open loop control system will become GS is equal to Ys divided by Rs. Now, let us discuss the transfer function of closed loop control system. In the case of closed loop control system, we have three major items to be used. In the first one is the error detector as shown in this diagram, the system itself which is the GS, and a feedback process which is represented as a HS. The feedback is connected to the error detector. The input for this overall system is Rs, while output of this overall system is Ys. Now, our aim is to calculate the overall transfer function of this system. In this system, we are looking that after the error detector, the output is Es, and this Es will be equal to Rs minus Bs, where Bs is the output of feedback process. This Bs will be equal to the multiplication of Hs into the Ys. As we will see Hs as a open loop control system, in this case the transfer function of this feedback process will be equal to Hs is equal to Bs divided by Ys. So, Bs will become Hs into Ys. Now, the overall output of this system is Ys is equal to Es into Gs. Now, put the value of Es which has been calculated from the error detector, that is Rs minus Bs. Now, place the value of Bs which is the overall output of the feedback process in this equation. Now, we will have the equation Ys is equal to Rs into Gs minus Ys into Gs into Hs. Take the common of output factor, that is Ys, on one side of the equation. In this equation, Ys will be equal to, in this case, Ys will be on one side of the equation, and that is the output, and input parameter will be on the another side. Now, our objective is to find out the overall transfer function of this system. So, overall transfer function of this system will be Ys divided by Rs, which will be equal to Gs divided by 1 plus GS into HS. Now, the overall transfer function of this closed loop control system will be equal to GS divided by 1 plus GS into HS. We can say the overall transfer function of this closed loop system will be equal to the ratio of the open loop transfer function, that is GS, divided by 1 plus product of feedback transfer function into open loop transfer function, that is GS into HS. Now, if there is positive sign on this error detector, in this case the overall transfer function will become GS divided by 1 minus GS into HS. Now, we can compare that the transfer function of this with the open loop control system. We have seen the open loop transfer function is GS only, while the transfer function of closed loop is GS divided by 1 plus GS. Now, in this case, we are looking that there is a factor of 1 divided by 1 plus GS which has been multiplied with the open loop transfer function, with that is the GS. Now, by calculating the transfer function, we can be able to find out the stability of the control system, which will help us in the analysis of the control system. Thank you very much. This was all about the transfer function and the representation of control system in both the ways, open loop control system and closed loop control system. Namaste, Dhanyavad.